section. Once again, you are welcome to today's class. Today we'll be looking at another brand new topic. Another topic called probability. We'll be looking at having studied the past questions of this examination bodies, WAEC, NECO, and GC. This is one of those topics where you have at least appearing at least 5 times in a 9-year period where I studied, under which I studied their trends and patterns. Now today, we're looking at this topic, probability. What then do you mean by probability? Probability means this likelihood, the chance that a particular event will occur. Probability is the likelihood, the chance that a particular event will occur. That is, now we say something will happen, but something may happen. So that is what probability is all about. So we are trying to look at the mathematical way of representing likelihood or the chances of the occurrence of an event. Now, how do we measure probability? We are trying to measure probability, we are trying to measure chance, we are trying to measure the likelihood of an event occurring. Now, when we say probability, probability is not zero. Probability is not zero. Probability is not 1. Probability lies between 0 and 1. Probability lies between 0 and 1, which means probability is greater than 0, and probability is less than 1. Probability is greater than 0 and probability is less than 1. It can be 0, it can be 1. It's in between 0 and 1. That is, 0 is less than probability, but probability is less than 1. So anytime you solve any question of probability, you get your answer to be 0, it is wrong. You get your answer to be 1, it is wrong. It is only when you had all the possible events, which we call the sample space, in a particular situation that you can have 1. All the possible events you can have 1. But a particular event within a sample space can never be 1. It can never be 0, it can never be 1. It is between 0 and 1. So 0 here is an impossibility. So it is not a probability. 1 is a possibility or a certainty. We call it a certainty or a possibility. Here lies probability. Between 0 and 1 is where we have probabilistic events or occurrences. Now, how do we solve for probability? How do we measure probability mathematically? Now, probability is equal to number of required outcome. This is the general formula for probability, all over number of total outcome. So all the outcomes in an event are what we refer to as sample space. Number of required outcome all over number of total outcome, or number of required outcome all over sample space. Example 1. We have something here. A box contains 4 red, 8 blue, and 12 green balls. A box contains 4 red, 8 blue, and 12 green balls. Full stop. If a ball is picked at random, what is the probability that it is A, a red ball, B, a green ball, C, a blue ball, Let's look at this question together. A box contains 4 red, 8 blue, and 12 green balls. If a ball is picked at random, what is the probability that it is A, a red ball, B, a green ball, C, a blue ball? Now we have a box. There are different colors of balls in that box. The different colors are red, blue, and green. Now, of those balls in the box, 4 are red, of the color red, 8 are of the color blue, and 12 are of the color green in that box. Now, someone picked a ball from that box at random. Picking something at random, meaning that you just pick without having a foreknowledge of what you are actually picking, or you actually wanted to pick red, no. But you just picked a ball at random. You don't have a foreknowledge of what you are picking. So what is the probability that it is a red ball, a green ball, or a blue ball? Using this formula, number of required outcome all over number of total outcome. Let's have another question here. D, a white ball. A white ball. Let's have another one. A white, a blue, or red, or green ball. A blue or red. Okay, let's leave this out first. Let's solve these 4 questions, A to T. Let's solve A to T first. When we progress, we'll do something like this too. So we have A, B, C, and D. Now, this is what we do. Solution. First, you do the analysis. Balls now. Green. The color blue. Blue, and then we have red. How many green balls do we have here? We have 12 green balls. 12. How many blue balls do we have? We have 8. And how many red balls do we have? We have 4. So these are the colors of the balls we have, and these are their numbers. So total balls we have 12 plus 8, 20. 20 plus 4, 24. We have 24 balls in total in that box. Now, what is the probability of picking A, red? This is how it is written. We have a way of writing something in mathematics, so you don't have to write so much. Probability, P stands for probability of a red ball, R representing red. Probability of a red ball equals to, using the formula again, number of required outcome all over number of total outcome, or total outcome. Number of required outcome. Our required outcome in this case is red ball. Total number of red balls that we have in that box. So that's our required outcome. That's what we are looking for. Red balls. The red balls are 4 in number. Total outcome 24. So the probability of picking a red ball is 4 over 24. 4 here 1, 4 here 6. The answer is 1 over 6. If you check this now, it is 0.16. 0.16, you should give it 0.16, approximately 0.17, meaning that's why I said probability is more than 0. Probability is more than 0, but probability is also less than 1. So 0.16 is what we have if you convert that to decimal, but it is less than 1, and it is also greater than 0. So probability of picking red is 1 over 6. B, any red ball you pick is 1 over 6. The big question says a green ball, probability of picking a green ball. Don't forget the formula. This is the formula. Number of required outcome over total outcome, or number of total outcome. See the same thing. Probability of picking a green ball. How many green balls do you have here? 12. The first thing you do, analyze the question. Bring them out and then you solve. It makes it easier. This is 1 over 6. So number of green balls, required outcome, we have 12. Total outcome, 24. 24. If you look at this, 6 here 1, 6 here 4. 6 here 2, 6 here 4. Okay, 12 here 1, 12 here 2. Easily, that way, yeah. 12 here 1, 12 here 2. Probability of picking a green ball is 1 over 2. C. Probability of picking a blue ball. Probability of picking a blue ball. Probability of picking a blue ball. The required outcome is blue. What's the total number of blue balls we have in the box? They are 8. Blue, 8. 8. All over 24, the total outcome or the sample space. 8 here, 1. 8 in 24, 3. So probability of picking a blue ball is 1 over 3. Then the last one, D. Probability of picking a white ball. Look at this question again. We have 3 different colors of balls in the box. Red, blue, and green. Red, blue, and green. But this question says, what is the probability that a ball is picked at random? What is the probability that ball, that one ball picked at random is a white ball? Probability, white ball. From our analysis here, based on the question, green, blue, and red, we don't have anything like white ball. Because we don't have white ball, 0. Total outcome, 24, which gives us 0. That is, it is impossible to get a white ball from this box. That is why the probability is 0, meaning that, like I said earlier, 0 is an impossibility, 1 is a certainty, but 0, between 0 and 1 is where we have probability. So the probability of picking a white ball from a box that contains red, blue, and green balls is 0. That is why we have it here. White ball, there are no white balls here, 0, all over. Total number, 24, then the answer is 0. Meaning that probability of picking white ball is impossible. It is an impossibility. So, this is the formula, and this is how to solve anything probability. Example 2. So another example, the probability that it will rain tomorrow is 3 over 5. The probability that it will rain tomorrow is 3 over 5. What is the probability that it will not rain? The probability that it will rain tomorrow is 3 over 5. What is the probability that it will not rain? Now, let me explain this. When we have something like this, the probability that something will not happen is usually 1 minus the probability that it will happen. The probability that something will not happen is usually 1 minus the probability that it will happen. Also, the probability that something will happen can also be said to be 1 minus the probability that it will not happen. This question has given us the probability already, has quantified the chances that it will rain. We have a measurement of the chances that it will rain tomorrow here already, as the required over total outcome here already. Now, the question says, what is the probability that it will not rain? So, probability that something will happen, something will not happen, is 1 certainty minus probability that it will happen. Or probability that something will happen can be said to be the same thing as 1 minus probability that it will not happen. Now, probability that it will not rain. Probability that it will not rain. Now you have to be able to analyze, interpret a question. Your interpretation of the question will help you to solve it and get the correct answer. Now, probability that it will rain is the same thing as 1. So the probability that it will not rain is the same thing as 1 minus probability that it will rain. Probability that it will not rain is the same, is equal to 1 minus probability that it will rain. Probability that it will rain equals to 3 over 5 according to the question. Therefore, probability that it will not rain, probability that it will not rain is equal to 1 minus 3 over 5. Like we said, probability that it will not rain is the same thing as 1 minus probability that it will rain. So, probability that it will not rain is equal to 1 minus probability of raining tomorrow, 3 over 5. Let's do this. 1 is the same thing as 1 over 1. The LCM is 5. LCM of 1 and 5 is 5. We have a 5 here. 5 divided by 1, 5. 5 times 1, 5. We have a 5 here. Minus 5 divided by 5, 1. 1 times 3, 3. 5 minus 3 gives us 2 all over 5. So probability that it will not rain tomorrow is 2 over 5. While the probability that it will rain tomorrow is 3 over 5. Let's say that again. Probability that something will happen is the same thing as saying 1 minus probability that it will not happen. Probability that something will not happen is still the same thing as saying 1 minus probability that it will happen. So that's the other way. Example 3. Example 3. Example 3. Now let me quickly explain this before we solve this next example. Now when you interpret a question, like I said earlier, your interpretation of the question will determine what you use and how to solve the question. When you interpret a question, please listen to these rules, take note of these rules. When you interpret a question to have or, that means you will add up all the probabilities. When you interpret a question to have either or, you will add up all the probabilities or the possible occurrences. When you interpret the question to have and, you will multiply all the possible occurrences. Again, when you interpret a particular question, then for your interpretation, you have either or, you will add up all the probabilities. But when you interpret the question to have and, that means you will multiply all the probabilities. We have this. A bag contains 10 red, 20 blue, and 22 white balls. Two balls are picked. Two balls are picked at random. Two balls are picked at random. A bag contains 10 red, 20 blue, and 22 white balls. What is the two balls are picked at random. Now we are picking two balls from the bag. What is the probability that A, both are red, B, they are red and blue balls? Please, when you have this question like this, make sure you pay attention. Two balls are picked at random. That is, the two balls are picked at the same time, picking two balls straight from the bag. What is the probability that both balls are red? B, they are red and blue balls. Now let's do the analysis again. We have red, the colors. We have blue, and we have white. Red R, blue we call it B, white we call it W. Red balls, how many do we have here? We have 10. Blue ball, how many balls do we have? 20. And white, we have 22 white balls. Total 52 balls all together in that bag. We have 52 balls in the bag. 52 balls in the bag. Now, what is the probability that both? Now, remember, two balls are picked at random from the bag. What is the probability that both balls are red? Probability, both red. Both red. Remember, there are two balls. Now, how do we interpret this question? Both red. Like I said earlier, your interpretation of the question will determine what you are supposed to do. If you interpret a question to have such that your interpretation has either or, you will add up all the probabilities. When you interpret it such that it has and, you will multiply all the probabilities. When it has neither nor, you subtract. But the common ones are this and this. Probability that both are red. Remember, there are two balls. You say red and red. That is the interpretation. Red and red balls. That the two balls are red. Meaning, probability of red and red. That is how to interpret both. That is the two of them. Two balls are red. Red and red. That is how to interpret it. So, we have it this way. Probability of picking a red ball from what we have here is red ball, the required outcome 10 all over. Total outcome 52. That is it. Now probability of picking red and red. Remember, our interpretation says and. That means we are multiplying the probabilities. So probability of both red is equal to 10 over 52 times 10 all over 52. That should give us 100 all over 52, 52, 104, 0, 26, 2704. 100 all over 2704. 100 all over 2704. So that is, you can still break this down. You can still break this down. But the probability is 100 all over 2704. That's what we have. Probability of both, that the both balls picked are red. They are two balls. If there are three, you say red and red and red. If there are four, red and red and red and red, depending on the number of balls that are picked from the bag. So your interpretation of the question will determine what you are going to use. If you are supposed to use and in your interpretation and you use or, automatically you'll be getting the wrong answer. So if you are supposed to use or and you are using and, you will be getting the wrong answer. The key is trying to understand the question. The two balls are picked. They pick the two balls at the same time from the bag. Except the question says the two balls are picked one after the other. We get to that. The question is saying two balls are picked. That is, the person picking the ball picked just two. And then picking the balls, they realize that the two balls are red because they are two balls picked. So red and red, both. It's used to refer to two things, both. Now, B, they are red and blue balls. Now, let's look at the B question. They are red and blue balls. They are red and blue balls. Red and blue balls. Now, this probability of red and blue. Now, let's look at the probability of red. Probability of red balls is equal to 10 over 52. Probability of blue, the required outcome here, blue, 20 over total outcome, 52. The question says red and blue ball. So probability of red and blue is equal to 10 over 52, and we multiply probabilities times 20 over 52. We'll be having 200 all over 2704. So the probability that the two balls picked at random are a red and blue ball is 200 all over 2704. We're looking at a fresh topic, a different topic. One of the topics you always find in your past questions. Because having studied the past question over a 9-year period, I observed this topic came out at least 5 times between 2013 and 2018. So the topic we'll be looking at today is we'll be looking at the topic trigonometry. We'll be looking at the topic trigonometry today. Here we'll be dealing with triangles. We'll be trying to solve angles in a triangle. But we don't deal with any triangle. The only triangle we deal with, we use the right angle triangle. Don't forget we have the right angle triangle, the scaling triangle, the isosceles triangle, and the equilateral triangle. But the triangle we deal with in trigonometry here is a right angled triangle. This is a right angled triangle. A right angled triangle is a triangle where one of the angles is already 90 degrees. This is the kind of angle, the triangle we use when dealing with trigonometry. Now, before we go into this topic proper, let's quickly, briefly talk about the trigonometric ratios. The trigonometric ratios, where we talk about the SOHCAHTOA, this mnemonic SOHCAHTOA, SOHCAHTOA. Now, what does this stand for? What does the S, the O, the H, the C, the A, the H, the T, the O, and the A, what do they stand for? Don't forget, we are still using the right-angled triangle. We are still using the right-angled triangle. That is what we are going to be using all through. Now, first, these sides have their names. In trigonometry, they have their name. They all have their names. This is the angle subtending the right angle. This is where we call the right angle. This is why it is called a right angle triangle, because it has a right angle. This side is already 90. This angle is already 90. This and this place, we take the remaining 90 degrees, making it 180. The sum of angles in a triangle is 180 degrees. Now, the side, these are the sides of a triangle. Now, the angle, the side subtending the right angle is called, we have a name for it, we call it the hypotenuse. The side subtending the right angle is called the hypotenuse. Here we call the opposites. Here we call the adjacent. Let's assume we have here alpha. Let's assume we have here alpha. This angle is represented by alpha. This becomes the opposite. This is the hypotenuse and this is the adjacent. The hypotenuse is the longest side in a right angled triangle. The hypotenuse is the longest side in a right angled triangle. Where the given angle is facing is called the opposite. Where the given angle is facing is called the opposite in a right angled triangle. Where this angle is facing is called the opposite, not the right angle triangle, not the right angle rather. Where the given angle, this is the given angle, signified, represented by alpha, is facing here, this place becomes the opposite and this place becomes the adjacent. Hypotenuse, opposite, and the adjacent. Now, what is SOHCAHTOA? The ratios now. Let's first talk about the trigonometric ratios. SOHCAHTOA. S stands for sine, and sine, the ratio is this over this. O over H. Opposite, O stands for opposite, H stands for hypotenuse. Let's go to C. C stands for cosine, or in short form, cos. You can call it cos. Sine, call it cosine, cos. This is A over H. A over H. A stands for adjacent. H stands for hypotenuse. Now, tangents. Tangent, we call it tan. For short, call it tan. O over H. Opposite over adjacent. So these are the trigonometric ratios we have. S stands for sine, opposite over hypotenuse. We have it here. C stands for cos, cosine. Adjacent over hypotenuse, this is it. And T stands for tangent, tan, short form. Opposite, O over A. These are the trigonometric ratios we have. Sine, cosine, and tangent. Don't forget SOHCAHTOA. O opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now, the next question is this. When do you know you are supposed to use sine, cos, or tan? When do you know you're supposed to use sine, so calculate an angle, cos, or tan? Now, let me give you some of the tips. Sine. let's talk about sine first. You use sine when
Are you going to do this writing for some time?
Yes. Now, when do we use sine? When do we know we have to use cos? And when do we know we are supposed to use tangent, tan? Don't forget, these are the ratios. Sine O over H, opposite over hypotenuse. Cos A over H, adjacent over hypotenuse. Tan, opposite over adjacent. Now, one of the reasons students miss this or find this difficult is because they do not know when they're supposed to use sine, when they're supposed to use cos, and when they're supposed to use tan. When do you use sine? These are some of the reasons or some of the situations that will make you use, conditions that will make you use sine. 1, when the hypotenuse and the opposite sides are given, but the adjacent side is not given. When you are given this side, and you are given the opposites, wherever the given angle is facing is where we call the opposites. In this case now, this angle, alpha, is facing here. This is the opposite. This becomes the adjacent. Don't forget, the longest side in a right angle triangle is the hypotenuse. So when you are given the hypotenuse and the opposite, just like we have here, but the adjacent is not given, you are supposed to use sine O over H. Also, take note of this. When the unknown side, what we call unknown in mathematics, are those values represented by letters like A, B, C, X, Y, and all of that. When the unknown side is opposite the given angle, with the hypotenuse also given, then we use sine. The unknown side is opposite the given angle, which means that unknown side that is opposite the given angle automatically becomes the opposite. Is given. And then the hypotenuse is also given, then we use sine. When do we use cosine? We use cosine of angles when? 1, when the adjacent and hypotenuse sides are given, but the opposite is not given. When you are given A and H, but you are not given O, you use cosine, cos. Also, you use cos when the unknown side, take note, the unknown side, those are the sides represented or values represented by letters A, B, and all of that, X, Y, and so on. When the unknown side is adjacent the given angle. When it's adjacent to the given angle, and with the hypotenuse given. When the unknown side, that is the side represented by a letter, is adjacent to the given angle, and with the hypotenuse given, you use cosine, cos. When do you use tan, tangent? When the adjacent and opposite sides are known or given, but the hypotenuse is not given. In simple terms, you use tan when you are given, when you are not given the hypotenuse. That is that. You use tan when you are not given the hypotenuse. Now let's consider this example. Example 1. Find the value of x in the diagram below. We have triangle ABC with angle A 60 degrees. We have side BC 5 centimeter. 5, let's call it 5 meter. 5 meter. And we have side AB to be x. Find the value of x. So let's look at this. Let's solve this together. Solution. Find the value of x in the diagram below. That's the diagram. You can see it there. Angle A is 60 degrees. Angle C is not given. Side BC is 5 meter. Side AB is x. Find the value of x. How do we find the value of x here? So we are going to use the trigonometric ratios because it's a right angle triangle and we have the angles given and sides given. Now, look at this. This is the given angle, 60 degrees. Not 90. We are not dealing with this right angle. No, we are dealing with the other angles given. 60 degrees is the angle given. we can see this 60 degree is facing, yeah, this is the side facing 60 degrees. That means this place becomes the opposite. It means this place becomes the opposite. Automatically, we know already this is the longest side. It is the hypotenuse. The longest side is that side AC, which is the hypotenuse. This is where this angle is facing this side. This place becomes the opposite side, and this becomes the adjacent side. Wherever the angle is facing, this is how to know your hypotenuse. Wherever the angle given is facing is called the opposite. So we have our hypotenuse there, the opposite 5 centimeter, and we have our adjacent x. Now, these are the conditions necessary for the use of sine, cosine, and tangents. Now, we are given the opposite 5 centimeter, and we are also given the hypotenuse, which is, we are also given the adjacent, which is x. This is the opposite, and this is the adjacent. In this case now, hypotenuse is not given, and that's what we said under tangents. When the adjacent and opposite side are known or given, but the hypotenuse is not given. In simple terms, whenever you are not given the hypotenuse, but you are given the two other sides, then you use tan. So we are going to use tan for this. Tan 60 degrees is equal to, tan 60 degrees is equal to, what's the formula for tan? O over A. Opposite, our opposite is 5 over A. Adjacent is x. Our opposite is 5. Adjacent is x. So by cross multiplication, we will be having x tan 60 degrees equals to 5. X equals to 5 all over tan 60 degrees. 5 all over tan 60 degrees. Tan 60 degrees. Tan 60 degrees should be giving us root 3. Tan 60 degrees tan 60 degrees gives us 1.7321. Tan 60 degrees gives us 1.7321. That means x equals to 5 divided by 1.7321. 5 divided by 1.7321, which is 2.886. 2.8, approximately this gives us, approximately this is 3 meters. Approximately 3 meters. So the value of x in this triangle below is 3 meters. We are supposed to use tan because the hypotenuse is not given, but the opposite, which is 5 centimeter, because that is where the given angle is facing, and the adjacents are given. Our adjacent here is x, so we are supposed to use tan. We use tan when you are not given the hypotenuse. That is as simple as that. We use cos when the adjacent and the hypotenuse are given. We also use cos when the unknown, when the hypotenuse is given and the adjacent is given. That is also when you use tan, when the unknown side is adjacent to the given angle and with the hypotenuse given. You also use sine when the unknown side is opposite to the given angle and with the hypotenuse also given. So in this case now we use tan because we are not given the hypotenuse. So tan 60 equals to 5, which is our opposite. 5 is our opposite, and x is our hypotenuse. Don't forget, wherever the given angle, this is the given angle, not 90 degrees. Wherever the given angle given is facing, that is where we call the opposite side, which is our 5 all over adjacent, which is x. Tan is O over A. By cross multiplication, x tan 60 degrees equals to 5. X equals to 5 all over tan 60 degrees. 5 all over tan 60 degrees equals to 1.7321. 5 divided by this gives us 2.886, approximately 3 meters. So x is equal to 3 meters. That is that. Now let's consider another example. This is YX 2013. When one end of a ladder, LM, the LM representing both ends of a ladder, the up and the down, is placed against a vertical wall. One end of a ladder, LM, is placed against a vertical wall at a point 5 meters above the ground. The ladder makes an angle of 37 degrees with the horizontal ground. A, represent this information in a diagram. B, calculates correct to 3 significant figures the length of the ladder. Now, let's solve A. That's a sketch. This is, let's say, the wall. Your wall can be here, your wall can be there. Your wall can be here, your wall can be here, depending on how you want to draw it. However you draw it, you still get the same thing. Now, let's assume we have the wall here. This is the wall, vertical wall. When one end of a ladder is placed against a vertical wall at a point 5 meters above the ground. Now, the ladder is placed against, leaning against the vertical wall. Let's say this is the ladder. You know what a ladder is? Leaned against the wall, 5 meters above the ground. Now, the wall is 5 meters above the ground. Where the ladder is leaning, it's 5 meters above the ground. It's placed against a vertical wall at a point 5 meters above the ground. That is where the ladder is placed. Measuring it above the ground is 5 meters. That is the wall, 5 meters above the ground, at the point where the ladder is resting, leaning against the wall. So 5 meters above the wall, the wall is 5 meters above the wall, up to the point above the ground, up to the point where the ladder is leaning against it. Then the ladder makes an angle of 37 degrees with the horizontal ground. This is the ground. This is the ground level. This is the ladder. This is the wall. This is the ground. Now, 5 meters above the ground, that is the wall, and where the ladder is actually leaning against it. That point, 5 meters above the ground. The point where the ladder is touching the wall is 5 meters above the ground. That is the interpretation of the question. Your interpretation of the question will determine if you are going to get the answer right or wrong. So understand the question, interpret it the right way so as to get the right answer. So they say LM are the two ends of the ladder. LM. You can call this place anything you like it. You can see it now. This becomes a right angle. This side becomes right angle. So it is a right angle triangle. So the question says the ladder makes an angle of 37 degrees with the ground, with the horizontal ground. The ladder makes an angle of 37 degrees with the horizontal ground, not with the wall. If it makes that angle of 37 degrees with the wall, it would have been here, because this is where it is touching the wall. But with the horizontal ground, and this is the second end. The other end, which is touching the ground, is where the 37 degrees is made. So we have here don't forget, assuming the question says the ladder makes an angle of 37 degrees with the vertical wall, then 37 degrees would have been here. But it makes the 37 degrees with the horizontal ground. This is the ground level. It makes it with the ground level. This is where our 37 degrees should be. So, this is A. Now, B says, calculate correct to 3 significant figures the length of the ladder. That is, when you calculate approximate to 3 significant figures your answer. The length of the ladder. Now, this is the ladder. Don't forget, this is the ladder. This is the ladder. The length of the ladder. Now, let's look at that. Let the length of the ladder be x. We are assuming now that the length of the ladder be x. Let's have our drawing again. We have it this way. We have it this way. At 37 degrees with the horizontal ground. This is the point at which the ladder touches the wall, and then measure down, you have measure to the ground level, you have 5 meters. And we are assuming that the length of the ladder, this is the ladder, the length is x. This is what we have now. The length of the ladder is x. By assumption, the other side is 5 meters. This angle is 37 degrees. Don't forget, it's a right angle triangle. We have this here. Now, we are asked to calculate the length of the ladder, which is x. Look at this also. This is the longest side, which is the x, is given already, which means we are not going to use tan. You only use tan when the hypotenuse is not given. We are given the hypotenuse as x already, so we are not using tan. This is where the angle is facing, 5 meters, which is opposite. That is opposite, 5 meters. That side is opposite. This is L, this is M, because this ladder LM. Let's call this place N. Let's call this N. So Ln is 5 meters, which is our opposite. This side is our opposite. This is our hypotenuse, and this is our adjacent. That side is opposite because the angle, given angle, is facing that side. So it is the opposite. This is the longest side, x, because it is the hypotenuse. We are looking for x, which is the length of the ladder. So we are given the opposites, 5, and we give it the hypotenuse. We are given the O and the H. That means we are going to use sine. Sine 37 degrees. We are using sine because we have been given the opposites and the hypotenuse. We have been given the opposites and the hypotenuse. The opposite is 5 meters, hypotenuse is x. Sine 37 degrees equals to opposite 5, hypotenuse x. By cross multiplication, x sine 37 degrees equals to 5. X equals to 5 divided by sine 37 degrees. X equals to sine 37 degrees. So x equals to 5 divided by sine 37 degrees. 5 divided by sine 37 degrees is 0.6018. 5 divided by 0.6018 gives us 8.3. So x equals to 8.308. 4. X point x equals to 8 points, correct to 3 significant figures. 8.31 meters. Correct to 3 significant figures. X equals to 5 over sine 37. 5 over sine 37, which is 0.6018, equals to 8.3084. But the question says correct to 3 significant figures. 8 adds 1 to this 0 becomes 1. So 8.31 meter is the value of x, which is the length of the ladder. The length of the ladder is 8.31 meters. Let's look at another example. The angle of depression of a point P on the ground from the top T of a building is 23.6 degrees. If the distance from P to the foot of the building is 50 meters, calculate, correct to the nearest meter, the height of the building. This is from WAEC 2014. Now, let's have a sketch of what the question is, what the drawing will be like. The angle of depression. Now, listen, depression is coming down, elevation is going up. So, when you are viewing an object or anything, we are standing somewhere up and then viewing an object down, the angle created is angle of depression. But when you are standing somewhere down and viewing something up, then the angle created is called angle of elevation. So depression is coming down, elevation is going up, down, up for elevation, down for depression. Now the angle of depression from a point P, now that means the point P, from a point P on the ground, from the top T of a building, the angle of depression of a point P on the ground from the top T of a building. That is, the angle is from the top of a building T. This is the building. Let's call this the building. This is the building. This is the building. The top of the building T. From of a point P on the ground. This is the ground. This we have the ground. This is the ground. The points of a point P. This is the ground. The points. You can have your building here and you can have your building here. The same thing. We end up producing the same thing. So the angle of depression of a point P on the ground. This is the point P on the ground. From the top T of a building. This is the building. And this is the top of the building. From the top of the building. Assuming it says from the ground. It's another thing entirely. But it is from the top of the building. Angle of depression. This is the top. From the top. From. Take note of the word from. From. If it says from the ground, this is where the angle will be. If it says from the top, this is where the angle will be. From the top of a building. From the top. This is where our 23.6 degrees should be.